Good afternoon. Welcome to the session Version Management with ArcGIS. I'm Annie Sassadar, Product Engineer in the Geodatabase Development Team, sharing this virtual stage with Kevin Watt, Senior Developer on our team, and Eric Hole, Group Development Lead. This session will present some of the technical details behind the branch versioning model that was developed for ArcGIS Enterprise and ArcGIS Pro. I will take a few minutes to give a high-level overview before I hand it off to Kevin to share how the database table structure has changed to support branch versioning and what makes this model performant. Eric will present the new version management server, REST API, and will highlight common workflows from a REST API client perspective. Let's start with the basics. What is branch versioning? It is Esri's new long transaction model, which allows traditional versioning workflows to be performed in a services-based environment. It builds on the well-established capabilities of traditional versioning, like multi-user editing and edit isolation in child versions. It is through the version management server capability that key version administration tasks are now performed through services. Some of the benefits of this new model is that it is based on the geodatabase temporal model, which archives edits in a single table, so version queries are more performant as there is no need of joining any dependent delta tables like traditional versioning. Kevin will be explaining this concept further in his section. With traditional versioning, it was a required administrative workflow to reconcile versions with default, so that the default lineage is not pinned by any version to achieve a full compress. With branch versioning, there is no such requirement. You reconcile a version when you are ready to get changes from the default version. With branch, the big bonus is that there is no need for compress. With branch versioning, we have the ability to directly edit default version in Pro or any version via the REST endpoint without an edit session. Since there is no exclusive lock on the default version, multiple versions can post in parallel. When you enable branch versioning on a dataset, archiving is enabled without requiring an additional step. Enhanced editor tracking capabilities allow you to also track users who delete features within a version. Conflict resolution can occur over multiple sessions. You can also add notes or comments, mark a conflict as reviewed during the QA process. The REST endpoint has different methods that can be used to perform versioning operations. Eric will go in depth on these and also provide code snippets on how these can be used. If you are using Pro as client, the versioning UX and the UI will be the same between traditional and branch versioning. The version manager is still the view you use to manage your versions. The versioning ribbon and the geoprocessing tools work with the branch versioned workspace. All versioning operations are termed the same. You still as a user create, alter, delete version as needed. As the version owner, you can set up the access type on the version so that users can either not see the version because it's private, see it but not edit it because it's protected, or both see and edit the version because it's public. You reconcile versions when you're ready to pull changes from default version, detect the conflicts, and then resolve them and post the version. There are some underlying differences between the two versioning models. With branch, version creation and management is available only through services. As a flatter tree structure was recommended with traditional versioning, with branch this is enforced. You can only create child versions of default and all versions are siblings. After the datasets are registered as branch versioned, version editing needs to be done as portal users who have access to the web feature layers and are part of a role that includes the edit privilege. So in client-server connections, these datasets are read-only. In branch, insert, update, and delete are recorded as inserts in the underlying table, with appropriate timestamps. This allows us to track changes over time, including deletes. Editing in default version is a short transaction, so last in wins, and you cannot undo. When working with child versions, we support only one editor or multiple readers at a time. After you're done editing in your version, when you reconcile a version, there is an internal save that happens, and hence you cannot undo the reconcile operation like traditional. On reconcile, when conflicts are detected, you do not need to resolve conflicts in the same edit session as they are persisted. Once conflicts are detected, you can change ownership of the version to the QA person to continue the workflow to resolve conflicts, add notes, mark the conflict as reviewed, and then post the version. Branch versioning services can be consumed by any client that works with Feature Service Workspace, so it can be used in runtime clients or taken offline. The new solutions that we have developed are only supported with branch versioning. Branch versioning support was introduced with ArcGIS Enterprise 10.6. We support all the standard database platforms. For PostgreSQL, Oracle, and SAP HANA, the version is bolded here since version required to support branch versioning is different than the minimum version requirement for 10.6. To set up your data for branch versioning, you need to first change the geodatabase connection properties on the workspace connection to branch. Then on the data, you need to add global ID, enable editor tracking, and register the data as branch versioned. You then connect to the portal as a user with publisher privileges and share as web layer and select the version management capability. The team has worked on some enhancements to improve branch versioning workflows. With Pro 2.6 and Server 10.8.1, conflicts can be detected at column level. Prior to this, we only supported row-level conflict detection. To facilitate better performance in workflows such as batch updates or attribute rule evaluation, fields can now be filtered out from being marked as conflict. The Add Field Conflict Filter geoprocessing tool can be used to define the set of fields to filter from conflicts. The Python function list field conflict filters can be used to identify when a feature class or table has conflict filters defined. Subsequently, the Remove Field Conflict Filter geoprocessing tool can remove these conflict filters from the fields. In a collaborative effort with the portal team, we now have the ability to create a new custom role and grant the version management Manage All privilege. Any portal user that is assigned the new custom role can perform administrative version management tasks like reconcile post and manage all versions. Prior to 10.8.1, these operations could only be performed by the portal user that owns the service or the portal admin. We have a blog that goes into details on how to set up this role. A link to the blog is included in the references section of this presentation. With Pro 2.7 SDK and Server 10.9, you can now query the version management REST endpoint of feature services against the default version to determine features or object IDs that were edited between two moments. Also, to support phase development projects where design teams can check in approved designs incrementally to provide updates of a project, they can call post operation on simple features that are not part of a controller dataset with a list of IDs as the selection set to partially post some edits from a version to default. Handing it now to Kevin to describe how the database schema has been updated to improve query performance.
Thank you, Annie. And now let's take a closer look at the components and database queries used by branch versioning. Branch versioning uses time to define the edit moment. Unlike traditional versioning that used an integer state ID to record an edit moment, Branch versioning uses a database timestamp data type to record the edit moment in milliseconds. Analytic functions, which are database functions, sort and aggregate the information based on time in ascending or descending order. Enabling branch versioning to a table creates 4 new fields and indexes to the table. The GDB branch ID, which is the version identifier that is used during selections to isolate the edits, the GDB from date, which is the edit moment in fractional or milliseconds, the GDB is delete, which is the delete status of the row, and the GDB archive OID, which is used as a unique row identifier used by our analytic queries in branch versioning. Branch versioning uses 2 system tables, the branches table and the branches table modified. Creating a version inserts into the branches table metadata and moment information about the branch. Operations such as editing, reconcile, and post update the branch metadata moments used by branch versioning queries. The branches table modified is used to record edit moments of the branch, the table or registration ID, and the edit moment. When editing against default, all edits, inserts, updates, and deletes are considered inserts to the base table. In default, commits occur on every edit operation, and save and undo are not supported. In this example, 4 rows are inserted into the base and branch table at different moments. When editing against default following the creation of the branch, edits are made to the base table based on branch ID. But unlike default, undo and redo can be applied against the edits, moving the current edit moment back in time. Edits are then saved, where a trim operation, which we will discuss, clears the edits against the name branch. So now let's look at the current moment query against default. The first thing we notice is that nested queries have a select within a select that returns a row ID. Recall from the data model that a unique row identifier is used to return the row efficiently from the nested analytic query. In this example, we're using the row ID. The row ID here is from Oracle. Different versions of the query running against different platforms, such as SQL Server and Postgres, that don't expose an internal row ID will use the GDB archive OID. We see that the filter used by the analytic function uses a default branch ID 0 and a GDB from of infinity, which represents the current moment. The analytic query portion of the query first begins by partitioning by object ID that then orders the set of object IDs by GDB from date in descending order. The row number function of the analytic then returns a row number value of each partitioned object ID ordered in descending GDB from order, where the outer filter of the query returns the current row based upon the row number value of the ordered set of object IDs, and where the isDelete is equal to 0 or not deleted. The next example we're going to look at is at a branch query selecting the current rows from a branch and default. Branch queries against default use 2 ORed filters, one against branch and one against the default as an access path to the data. The analytic part of the query uses both filters, ordering each partitioned set of object IDs in descending GDB from order. Rows from both filters are then combined, creating a final result set where the outer filter begins to remove rows from the set. All rows are eventually processed in order of object ID until all rows have been removed from the set. As an insert model, one might ask, are rows ever deleted from a branch table? Earlier, we showed an example where during an edit of a named branch, a save was performed following an undo that cleared or deleted rows from the table. Branch versioning has a trim operation that deletes edits from a named branch to remove forward edits caused by undo and dead rows. Trim is also used during reconcile prior to conflict detection to delete rows from the tables modified during editing. Reconcile also uses deleted rows from the branches. Reconcile also deletes rows from the branches table modified following a trim. So going back to our early example, where we're editing against a name branch, we undo and save. That executes the trim, where two delete statements, one that finds forward edits and one that finds dead rows, are executed to remove rows from the table. So in summary, branch versioning uses time as an edit moment. Analytic functions filter by branch ID and time, and editing against default commits on every edit operation. Editing a name branch commits on save and performs a trim to delete rows from the base table and branches table modified. And now Eric will present Version Management Server.
Okay, now that we understand some of the details regarding how the branch queries work, we're going to talk a little bit at a little bit higher level about the version management server, as well as the Pro Managed SDK that you can use for .NET programming against the versioned API. Let's see. One thing, talk very quickly. It's important to note that the version management service, it's part of a constellation of services that we have developed that are meant to complement the feature service. The version management server exposes some managerial capabilities that work in concert with feature services whenever you're working with branch versioned data sets. Now, it's important to keep in mind, as was mentioned previously, that the version management service does not work with traditional versioning. That being said, you can see the version management service, or what it's responsible for, is things such as creating and deleting versions, altering versions, controlling the service sessions when you're editing your data, being able to do your reconciles and your posts, as well as then managing the conflicts that may occur when you do a reconcile operation. Now, here's a graphic representation that shows the version management server, where we have our root resource as well as the versions and version resource themselves. And you can see the various different operations that are found on various different resources inside this constellation. When we talk about it, the root resource, that's what in your URL, the version management server is. We have the versions resource, which is basically a gateway or a resource that controls the individual versions. And then we have individual version resources themselves. And in the URL, you'll be using the version GUID as part of the URL when you're working with a version resource. Now, when you do go and talk to the version resource, if you ask it for just its default JSON response, this is what you see. You'll see some information. It says, of course, I'm a version management server, I'm a map server extension. What is the name of the default version? And what is the GUID representing the default version? Starting at 10.8.1, when we were adding additional operations and capabilities to our various different the version management service, we added these capabilities that are Boolean properties that you can query. So at 10.8.1, we released supports conflict detection by attribute, or supports historical markers. That'll be a true-false response. At 10.9, we added in things such as supports partial posts or differences from moment. Okay, those were new things that we added. You can pass in the format equals schema to the root resource, and you can get different information back. You can get first an enumeration of all the operations with their names and parameters and all that. You can also get a list of the resources that are configured inside the service. And F equals schema is supported on all of our services. When we look at the versions resource, if you probe a versions resource for its metadata, what it will do is return back to you a list of all the versions, the essentially tuples of the version name, as well as the grid representing that version. So in the response example at the bottom, we see the default version along with its GUID that begins with BD3F. Then there's also another version apparently in this example called Project A, and it has a different version GUID. And these version GUIDs are what you will use when issuing your URL requests, your request to the version management server. And if you actually connect to an individual version and ask that resource for its metadata, it will respond with a larger collection of information, such as its name, the GUID, and then other key metadata: when it was created, when it was last modified, when it was last reconciled, when the common ancestor date is. Is it locked? Who is the lock owner? What kind of access does it have, public, protected, or private? All the things that you would expect from an individual version and its metadata. Now, let's look at examples of doing things with these services. You can, of course, create a version. This is just looking at our API spec, some of the parameters and what they represent, and all the rest. And on the bottom, we have the actual. We actually have the request to the service, to the version management server, and the create operation on that. Passing in the token, format equals JSON, as well as the name of the new version that you're trying to create, in this instance, my new version, and the access permissions that we want to run with, which in this case are private. Pretty simple. If on that version we wanted to start editing on it, we'd again talk to the version management server, and we would pass in as part of the URL the version GUID. That's represented in green. Then the start editing operation, and then the list of parameters such as the token, the format, as well as the session ID. The session ID is essentially a client-generated session ID or GUID for the version that a new service edit session is being started on. Okay, and that is a required parameter, and you will use that in subsequent calls. So this is one that the client will generate. That's in orange. When you want to apply your edits to do your edits on the client, you want to apply them to the feature server, you'll call the feature server's apply edits operation, passing in, of course, the token and all the rest. You'll use that session ID that you generated on the previous when you did start editing. That's the same session ID. And then you will specify the version that you're editing. And this version is not the version GUID, but the actual name of the version. That's one area where the feature server and the version management server differ. When a version name is part of the parameters, it's currently just represented by the version name. If it's in the URL, it must be as a GUID. Now, when we're done with editing, let's say in this example, we want to discard our edits. We want to get rid of everything we just did when we're editing a named version. In the bottom, you see the REST request where we're again talking to the version management server. We're passing in the green version ID, as well as calling the stop editing operation with a session ID, and then save edits equals false. And that's how you would discard the edits that you did inside your service session. Let's talk a little bit about the Pro Managed SDK. The Pro Managed SDK is actually interesting. You can find it inside the Pro Managed SDK under core.data, and it's basically a C# API, API intended for .NET programming. It's actually powered underneath the covers by ArcGIS. So if you look in this little layer cake diagram at the bottom, we have ArcGIS with a set of C++ bindings on top of it that allows the managed API implementation, which is written in a combination of C++ and C# to expose a managed API such that the client applications written in .NET or C#.NET can actually make use of them. Okay, and this has been in Pro for quite a while. What's interesting about this API is, it's a simplified API. It's designed and implemented using very standard C++ patterns and idioms, idiomatic ways of doing things. So if you're a C# developer, it should be completely natural to you. You're not having to try and pretend that you're a C++ ArcGIS developer. This should be very familiar to you. It's designed to be minimally complete. We're only exposing what is absolutely essential, all the essential abstractions and things necessary to do your work. Being a managed API, it is strongly typed, and we try to minimize the amount of object type casting that you have to do to use it correctly. Things in the API are readily discoverable through code completion and all that. Let's see, also, it does provide really nice support for exception handling, something much better than what you would see with traditional ArcGIS development, where you just see things such as H results. Now, the managed SDK for the geodatabase was focused on data manipulation, meaning that it was originally not authored to allow you to perform schema creation or schema modification, doing things like creating tables or adding fields, domains, coded values to those domains. We took the stance that when you wanted to do schema operations of this sort, you should be using better tools or the more native capabilities of the system, such as using the Pro API. That's very good for doing data management tasks, as well as the rich collection of GP tools. Okay, GP tools can of course be called from C# code using the GP API, using as you can see below. Now, due to user feedback starting at Pro 2.7, we decided to extend that or change our focus, where we do actually provide some DDL capabilities with the Pro Managed SDK. Many of you users and business partners actually said, we want to be able to create and work with our own data. We want to be able to create file geodatabases. We want to be able to create tables and feature classes for storing information. We need to be able to create feature data sets for organizing the data. We'd also like to be able to create, delete domains, rename or modify existing data sets. So that is possible now. It was first introduced at Pro 2.7, and we've added even more. We're adding even more at Pro 2.8. However, GP and Python, using the Python API, is still the preferred way to do large-scale DDL type operations. But this does give you the ability inside your managed code to do some interesting things. For example, what you would do is you would use the schema builder class, where here in the code example, we're just creating a new schema builder, passing in the geodatabase, the reference to the geodatabase during initialization. From there, you would then go and create and define, say, for example, a table definition object if you want to create a non-spatial table. Then once that is all configured, you've defined your table definition, you would then pass that into the schema builder through the create operation to add it to the list of DDL tasks. And then ultimately you would tell the schema builder to do the build, and that would actually execute the DDL operations. Okay, so that's new at 2.7. We're providing more at 2.8. And then I expect it will continue to grow moving forward. One thing to keep in mind, almost all the methods that you have inside core.data should be called on the main sim thread. Okay, there's a lot of doc online when we talk about the managed SDK detailing this, but do pay attention and be sure that you're running it on the main sim thread. Now versioning. Let's talk a little bit about versioning. The managed SDK does provide the capability to work with versions. This is both branch versions as well as traditional versioning. These versions do not have to be published as branch versions through services. No, they can still be traditional client server, but this API will work with both models. You can do things like, of course, list all the versions in the geodatabase, look at their properties, connect to a version, be able to create, delete, manage existing versions, being able to look at differences, reconcile, and post. These are things that you also see echoed inside our REST API for services as well. Now, inside the Pro Managed SDK, this is just a quick tour. You have the Version Manager class, and that's available if versioning is supported on the geodatabase, and that's true is returned to that query. And you can get it from the geodatabase object through Get Version Manager. And again, the API works with both branch and traditional versioning. And these, you can see the various things. Now, one thing to note, if you are trying to look at the differences between tables and feature classes in different versions, you wouldn't go through the version manager class. You would instead go through the table class and call the differences method on it. Okay, pretty straightforward. Now, for an individual version, here's the version class, and you can see the various different methods on there. Basically all the metadata associated with the version, as well as key operations such as being able to alter and delete it, be able to reconcile and post operations, or even refresh the version. And the reconcile description is also used in conjunction with a version that allows you to specify how you want to do conflict detection. Do you want it by column, where conflicts are detected if the same attribute is updated in both versions, or you want it by row, where conflicts are detected if the same row is updated in both versions? You can also specify the conflict resolution method, the two ones there being abort, which means it'll stop the reconcile if conflicts are detected, or continue, which means that it will continue the reconcile if conflicts are detected. Finally, we have a conflict resolution type. You have two choices here. You can favor the edit version, which means that we will resolve the conflict in favor of the child, or favor target, which does the opposite. It resolves any conflicts in favor of the parent. And that's with traditional versioning only. That is not supported on branch versioning. Finally, a new capability that's being exposed is being able to do partial posting, where you can specify a selection of row objects and specify it inside your reconcile description as the partial post selections. And we will then go and partially post those to the default version. Okay, here's some example code. Pretty straightforward, using a common workflow, where we want to be able to talk to the version manager and get the default version and create a new version off of it. In this case, we can see it's creating a new version. We can do some edits to the actual feature class inside the version, do some work on them. Then we can do the reconcile and post of that new version with default. And then when we're all done with everything, we can go and delete the version. Sort of soup to nuts, all the things that you can do at a very high level. So, inside this presentation, we've gone through a lot of different things. We've given you a good overview of versioning in this. Given you an overview of versioning. We've talked a lot about the table schema, as well as what the query operations look like. We took you on a quick overview of the version management server, talking about the REST API and all that. And finally concluded with the Pro Managed SDK. Took you through some of the important classes and a few interesting tidbits there. And what's interesting about this is, certainly with branch versioning and the new version management server, it is exposed through our services through ArcGIS Enterprise, and that allows it to work with, of course, both desktop applications, mobile devices, as well as web apps and all the rest. So having the version management exposed through services is very key in order to enable the enterprise. And as you can see, we have functionality in each of these areas. Now, if you're looking for some references, read more about it. We have several blog posts that we're pointing you to right here, as well as some really nice API reference documentation you can get to. And we provided tiny URL links. You can also search for them very easily. Now, moving forward in the future, things that we're looking at, of course, performance and scalability. That's a never-ending task for us. We can always make things better, make them more performant, more scalable. We're looking at version posting queue, where you would be able to queue up versions that you want to have reconciled and posted. That's very important in enterprise environments. Be able to support difference filtering based upon a subset of the feature layers or a specified collection of feature layers. Direct support for historical markers through services, as well as other things that we're doing is simplifying the user experience for registering data as branch versioning. So that sort of concludes the operation. Anyway, we thank everyone for attending. And
You are.
Thank you. Thank you, everyone. I hope the session was helpful, and we are here to answer some of the questions. A good set has already been coming in, and we have been trying to answer those. We are now available, Eric and me, and Colin, to answer questions as they come.
Thanks, Amy. So there's a series of questions in the chat about branch versioning and the support for Workflow Manager. Specifically, they're asking which version is needed to adopt branch versioning with Workflow Manager. I don't actually know the answer, Amy. I believe that in 2.7, the Workflow Manager team did work in Pro to support branch version sessions, but I don't know that 2.7 is the minimum requirement. That would be my current guess.
Right, and I think at that point, I will also say, I think it is at 2.7 when they did add support. But if we will need to get back to you, you can come by the chat for Ask the Experts, and we can confirm that. I believe it is 2.7.
Yes, we are at the ArcGIS Enterprise Island.
Enterprise, yes.
Next question, can we enable both branch and traditional versioning on a geodatabase? So I'll take a shot at that one. The enablement of a registration type is at a class level, either a feature class or a table, or on the feature data set that contains a collection. Both types of registration can exist in a single enterprise geodatabase, but within a feature data set, it must be one or the other. So you can publish services from a enterprise geodatabase, which contains branch version data and traditional version data. When you are registering the class as version, you can set the workspace property to be appropriate for the version type that you want to register. So if you want it to be branch version, you set the property to be branch and then ask to register as version. Ted, I have no idea what your question is. Should the service version, I think you ended early. Okay, we'll come back to you. Can you publish multiple views of a branch service and allow different views of the edits to happen and then post to default? So I think we'll talk a little bit about the model for supporting branch version. Like I said, it's a registration type on the database, at which point you publish this service. When you publish the service, this enables the ability to create views. They're not actually views, not database views, but unique versions of that data. So can you publish multiple views? You can publish multiple services, yes. Each one of those services could contain unique versions. And then, yes, you could go through each of those versions and reconcile and post them individually. There's a question about manipulating the timestamp for features instead of having them tagged with the current date.
I think that's a user time question, actually. Yeah, the branch versioning is really all about transaction time. It's a temporal transaction time system. I think what the user is asking for is actually valid time or user time, where the user can specify, although at, on March 1st, I edited the data and created a record. The record corresponds to something in reality that actually existed on January 1st. In those situations, what you want to do is you're essentially asking for a bitemporal system. And what you don't want to do is manipulate transaction time, but you actually want to maintain user or valid time. And so that would become a user managed attribute that you can maintain that says when something in reality came into existence, as opposed to what our system does, which is when was it entered into the database? When was it last modified or deleted in the database?
Thank you. There's a question, is branch versioning going to replace traditional versioning? We've built both models to work side by side, like I explained earlier. Branch versioning is explicitly to support a service-based model, where we are effectively moving the database can from the local connection into the cloud with the service, and then all of the versioning works within that service. So it enables us to have long transaction isolation within a service environment with all of the versioning management tools that you're used to working with your enterprise geodatabase available via the service. Okay, here's an interesting one. Can you publish a feature service that has no spatial tables? I think I'm interpreting that question correctly. I do not know the answer myself. Can you publish a feature service that has only attribute data?
Or is he just saying, are they saying object
Non-
classes? Just publish a collection of object classes.
I actually don't know the answer. That would be an excellent one to ask the experts at the Enterprise Island.
Right.
I got a little bit of a response from one of the developers on Workflow Manager talking about when they swore branch versioning, and they said nearly 2 years now, I believe, off of the top of their head. They don't have a specific release number, but their time frame is somewhere around 2 years ago in ArcGIS Pro.
So there's a question that got upvoted and bounced off the bottom a little bit. Does branch versioning work with related tables? Their example are edit log tables. So I think branch versioning certainly works with the related tables, as in with relationship classes. No problem there. Edit log tables, I assume you mean some sort of auditing service. I'm not sure entirely, but branch version feature classes can participate with attribute rules, and attribute rules could be authored to do edit style auditing. I hope that answers that question. If not, please visit us at Ask the Experts and we can get some clarification.
Well, there's an editing model question. Can multiple people edit a version simultaneously? Absolutely.
Yes.
Not. No.
Right.
Single user only.
You can have only single user. Yeah. You can have multiple people reading it, but only one editor.
There was also a question, is there a way to delete edit history, leaving only the current moment records in the database? At this time, there's no way to remove or trim the archive history via an ArcGIS tool. This is definitely something that we're looking into. We're gathering requirements. We would like to hear from you at Ask the Experts, please.
Yes, yeah, the use cases would be very interesting here. We'd like to know.
There is a statement / question. There is a lot of good information in the chat. Can this be made available somehow, Brian? Brian, we will work with our documentation team to see if we can capture this information and maybe include it in some form, maybe a blog post. So I think there's a follow-on question, Eric, to your question.
Oh, the multiple geologists?
Yes, the multiple geologists.
Do we support geologists in ArcGIS?
I'm one, so I
No,
hope so.
they. Oh, wow, really?
Yeah.
I never knew that. Yeah, you can have multiple people all editing, of course, any data set in the system, but they can't be editing the same version at the same time. So let each geologist have their own version, then they can all edit it simultaneously. That's the intent of branch versioning as well as traditional versioning.
There's a question, Eric, about a future. Will it ever be possible to edit features in the future? So for planning, it is important to go in time, but in the future.
Oh, you could take that two ways. I think we'll support editing next release, but that's a different future I see. Yeah, that gets back to the whole bitemporal discussion, where you have, user time or valid time versus transaction time. We internally have had a lot of discussion about that. It's a very interesting notion, supporting a bitemporal system natively inside the geodatabase. We have a lot of interest. We're still trying to understand user requirements here and who's trying to would like to be able to do what in that context. So like Colin's been saying before, please provide more information if you care to share any. We would like to be able to, but there are no definite product plans right now.
Will partial post be available for branch version only?
Mm-hmm. Yes.
I mean,
Yeah, it's only on branch versioning.
like all our development work now is only focused for branch versioning. So
right.
That's when new stuff is coming.
Yes, multiple geographers are allowed to edit at the same time.
Well played.
Yes. So there's a question I just stated about branch versioning supporting multiple user editing. And I think this follows just the traditional versioning model too. We support multiple user editing. The only thing is that each one has their own version. So that's the only difference.
Oh, an interesting one asking about adoption outside of the utility network and parcel fabric space. Who else is using versioning? I think one of the things that you would say is large enterprise customers, very, very large enterprise customers have this general need. We focused certainly a lot in our discussions talking about the utility fiber telco space as well as the parcel management space. But when you have large organizations trying to maintain these big enterprise level systems, oftentimes they really do need these capabilities. So Colin, Annie, can you think of anyone, any particular area?
So I'll segue into the next question, which is how is topology supported? We support our topology users with branch versioning. It is another extension data set that's supported via a service layer. Those, management of spatial relationships is another case. Branch versioning is being utilized in a service-based environment. There's a question from a database perspective. Do you need to share from a connection with editing privilege, or can you share it from a regular connection? So with branch versioned classes, it is the owner of the data who is publishing the service.
And all the editing privileges are handled from the portal side once the service is published.
Eric, there was one question about the recording equipment behind you. You want to just mention that?
Oh, now we're talking about something interesting. Yeah, it's a TIAC 1500 reel-to-reel. For all you audiophile nerds like myself out there, it's pretty sweet. I'm very happy with it. I was taking it back into my, yeah, reel-to-reel tape recorder. Actually, no, it's a Techniques 1500. I'm sorry, I think I said TIAC.
Do branch versions have the same access levels as traditional versions?
Yes,
Public,
they do.
private, protected.
Mhm.
Yes.
Yes, that was part of the presentation.
Yeah, that's one of the things we took particular care to, is to keep the same basic user model, if at all possible. There are a couple exceptions, such as not having grandchild versions, but for the rest of it, we try not to change the nomenclature or the abstractions or anything at all like that. So it should just be very natural for you, for those of you that are familiar and happy with traditional versioning, to be able to utilize branch versioning.
So several more questions came in all at once. I'll try to get through each of them. Are branch versioning workflows being used over the WAN or LAN only? The service model is designed to work over a WAN as well. They are being used over both patterns.
It's like our data centers. We have ESRI internally. We have remote data centers in other states that we use for our testing and day-to-day work and all the rest. Yeah, it works perfectly fine. Of course, you'll incur maybe a little bit more latency if you're going tremendous distances, but yeah, there's no coupling to LANs or WANs.
Can the branch version data be compressed if such historic data no longer is required? I think this ties into one that we answered earlier. Maybe it was just in the chat. There is currently no supported trim operation through ArcGIS Pro. That is something that we're looking for workflows. You can reach out to us at Ask the Experts. We'd like to talk to you. Eric, this one might be for you. Will the branch versioning work with Session and Design Manager of ArcFM?
Yeah, Schneider Electric, our business partner that authors ArcFM, that's their product. Yeah, they've been very much engaged with us for ages, and they are working to ensure that their full stack is working appropriately with our service-based architecture and all of our new capabilities, such as branch versioning and the version management server and utility network server and feature services, all the rest. So I'm not sure, I can't comment directly on ArcFM as it's shipping today, but yeah, that's my understanding is yes, Schneider is working aggressively in that direction.
There's a question about branch versioning workflows enabled with Parcel Fabric specific feature classes. Parcel Fabric is an extension data set that supports branch versioning. Mm-hmm. Yes. Some of them are jumping around a little bit.
Yeah.
Amber, got to address that question. Ontario Kings missed it by that much. Hanshin Tigers. Japanese baseball out of Osaka.
There's a question
close
on
to Ontario.
Oops, sorry.
I just said Osaka, although it sounds like it's close to Ontario because they both start with an O, they're actually strangely separated. I'm not a geographer, but that's my understanding.
A question on how is branch versioning working with different time zones? So all of the temporal data that we store is in UTC.
Ontario Kings.
I hope I didn't miss anyone. There were some things upvoted that before I could read them.
Oh, Parcel Fabric. It only supports the branch versioning model. Yeah, being one of our new extension data sets, you know, services-based, works with branch versioning. I should have cleaned up this dumpy room I'm sitting in. This is embarrassing. Anything else?
There's a question, I think maybe this will be our, still coming in. Is portal a necessary requirement for branch versioning?
Yes, yeah.
It's part of ArcGIS Enterprise.
Yeah. And all the editing privileges and all are assigned through the portal.
Mm-hmm.
There's a question, has there been any discussion on bringing branch versioning to ArcGIS Online? Infrastructure and maintenance in ArcGIS Enterprise is not an easy lift.
I think there has been discussion. There's been no commitment. I think if I was to stand back and look at ArcGIS Online, I mean, there's considerable attention and effort being played to it, and its capabilities are being extended all the time, much like the rest of the ArcGIS platform. You know, we see that in runtime mobile space. We also see that in the web app space. Oftentimes sometimes things are initially implemented in Pro, and then Pro and Enterprise, and then they start to grow outward. And it is the intent, being a service-based architecture, that things such as online should be able to get there. I have not heard any particular time frame or commitment to do that, but it's a natural or a logical inference that you can make.
Can you publish a web layer from an existing web layer but point it to a named version? I believe that the UI for the web map doesn't currently enable that, but you can modify the URL to include the version parameter as Eric showed in the slides. I believe that is a capability that they're working on, though. I was just reading one about field map and then it disappeared. I don't know where it is.
I was too. Oh, I don't know where it went.
I will find it. There's one asking, and I'm not familiar with this piece of functionality, but field map app. Does the branch version carry over to the field map? If so, if we create a version for the field workers to edit, does this carry through to the field map app? Field maps, there's a series of questions about how branch versioning works with field map apps. I'm not familiar with the field map app myself, so I'm not sure.
We will need to get back to them.
Yes, we'll have to get back.
Is this just asking about how the app works with our service?
How field map apps work with branch version services. If you're have to take their version offline. Sounds like it's a runtime
Connected?
application.
No.
Reach out at Ask the Experts,
Yeah,
and we
I
can get
can
you in
now.
touch with the correct person.
Right.
It's funny when these things get up screens. Go to the top.
Very hard to keep track.
Oh, Ted Cronin said field maps replaces collector.
Mm.
Okay.
The new collector. Yep.
So I think what we can do is when we publish the answers to these questions, we can try to get that answer for you.
Right.
That's a good idea.
Okay, yeah. If there is one last question, I'll answer. Someone interpreted the question as a field map question. Looks like it's a question if the branch version can be published to a feature service itself. And the answer is no. You publish the base data and then create the versions inside the service is the best way to think about it. You can't publish a branch version from another service.
Okay. I think we are at a place where we're out of time. We will, the ones that we have not got to or you need further discussion, please meet us in Ask the Expert and we will. Thank you very much.